Hello all. Let me just share my screen. Can everyone hear me well? Can you see the slides? The people on the back can hear me? Yeah, sorry, this is a really bad joke, but I need to make it. Okay, nice. I hope everyone is safe and is having an amazing time at these virtual Android makers. For me, it's truly a pleasure to be here and to see how much the team was able to do face everything that's happening worldwide. And of course, not only the team, but also to you that apart from all of this chaos, decided to embrace this remote conference and joined us. So thank you. A big round of applause to you. I didn't realize how awkward it is to just applaud an empty room, but let's start. I've tried to pick a background for this talk to be something that we're all doing. So we're all comfy at our homes, drinking a beer, just watching these talks. So hello, welcome to my multi-platform talk. I really tried to learn how to say this in French. Bonjour. I could not say it properly, so I asked Google to do it for me.
Bonjour à tous. Bienvenue dans mon exposé sur Kotlin Multiplatform.
Okay, so welcome. My name, you can find me on Twitter at Carlos Mota. I usually tweet about Kotlin, about Android, about Kotlin Multiplatform, about some trips. Now I only take pictures from my living room, but you got the point. I've been developing for Android for the past 8-9 years, and for the past 1.5 to 2 years, I've got several side projects using Kotlin Multiplatform. I'm from Portugal, and I'm also a community organizer from GDG Coimbra. I believe the link was shared on the chat, but I've got a poll there with some questions. And if you have any questions that I will answer at the end, you can also ask them there. Also, these slides, I also shared the link on my Twitter and on this chat, but you can find them on my speaker deck. I believe they are also on this channel, so feel free to access the slides. So let's start. I would guess that most of you are Android developers, but do we have someone that's also an iOS developer from the web, from backend? I'm looking at the live poll, and well, 90% are Android developers, but we still have iOS and web and server side. Nice, really good numbers. So the good thing about here is that we have Kotlin in all of these platforms, as you will see. So let's start. This is the mobile world nowadays. So we've got Android and iOS, and if you pay special attention, I decided to pick pictures of these devices with the dark mode one, because this was the biggest feature of last year. Let's see what we're going to have this year. And let's imagine that we have a wild idea and we want to develop an application for Android and for iOS. And just a small thing here on this image, I tried to pick the best picture of a laptop, and all of them had a nail. I don't know what this means, but we also have someone programming PHP, so I'm guessing that it's related. But let's start. Imagine that we have a wild idea that we want to develop for Android and for iOS. So typically what the company does is they hire a team of specialized developers, they define the requirements, they design the mockups for both platforms, they plan the features, they start development and writing unit tests, they write a T-spec, and then they cross-check that everything is working as expected. And a special point here, please design mockups for both platforms. It's really important to give the same experience to the users that is already used to on native. So typically, we're going to have 2 times the team, the cost, the status meetings required, and probably not 2 times, but 3 or 4 times more. But we also have the 2 times the time spent on development, testing, and bug fixing. And now if you want to add, for instance, the web to this, we're going to just increase those numbers to 3 times more. The team, the cost, the status meetings, etc. So what we really want to do is to cut this in half. Okay, we want to have fewer costs and higher development phase and hopefully less specs. So let's try to find a solution for all platforms. And this is not something new. This started in 2006 with PhoneGap, and we've seen a couple of solutions since then. We've seen Xamarin, NativeScript, we've seen Ionic, we've seen React Native, Kotlin Multiplatform, and even Flutter are all solutions that try to improve this and allow the developers to develop at once and run in all platforms. A side note, this is not the entire goal of Kotlin Multiplatform, but we'll see that in a few slides. So typically, these have some direct advantages. You don't need 2 teams. You can have a smaller team. Typically, it will be half of the costs than doing everything native. And if your company already have someone from the web, the learning curve to start doing something, for instance, in React Native is quite small, and you can reuse a lot of components. So there are really good advantages here. Unfortunately, there are also a lot of disadvantages. And I want to say this first, but all of these advantages are a bit common on all of these frameworks. Nevertheless, this depends a lot on what you want to do. So I'm not saying that you shouldn't use a cross-platform solution. I'm just saying that this depends on the project. For instance, if I'm doing something that requires a lot of performance, I'm not going to do it using Xamarin or Flutter. But if this makes sense on your product, of course, you should use it. For me, the worst thing about these cross-platform solutions are 2. The first one is you're chained to the framework implementation of the UI. And I've seen this a couple of times already. For instance, there was on iOS a big redesign where they changed almost all of the components, and iOS has something like 80% of people that update their version to the newest OS. But if you're using an application that was developed with Xamarin, since those components are widgets and are developed by the Xamarin team, when you're running that application on the new iOS, they were still seeing the old UI on their applications. And they needed to wait for 6 or 8 months for the people on Xamarin to develop those new widgets so you could update your application. So for these 6 to 8 months, you are still seeing the old components. It's not the best experience that you want to give to the users. Another problem here is that you're committed to one framework, to one language, and we don't know how the future will be. So if you're talking about complex projects that require several years of development, are you sure you want to commit all your code base to something that you have no certainty that will be there in 10 years? Because if you're going to develop it native, you know that, Android evolves from Java to Kotlin, and the iOS evolved from iOS to Swift, but both languages work together, Java and Kotlin and Swift and Objective-C, so you don't lose your code base. Also, although it's a bit arguable, performance, it's not the same. Sometimes you need to develop some native code because it's not well implemented in the frameworks, and Android has a lot of fragmentation. And for now, Dart, in case of Flutter, it's not a widely used language. So how can we have the best of both worlds? You guessed it, Kotlin. So before we start, I always like to play this video because I think it's incredible. So it has a bit of sound, so...
Tyle keczupu Kotlin zmieści się na frytce. Tyle na kanapce. Tyle na burgerku. A tyle na żeberkach. O, a na szaszłyczku jeszcze więcej. Nie ma konserwantów, nie ma ograniczeń. Jesz tyle, ile się zmieści. Kotlin, I love ketchup.
Okay, so although it's fortunately coincidence, it's from an Iceland, unfortunately, and if you search for Kotlin on Google, you only find ketchup way on the last pages of Google, because Kotlin, the language, is the main search nowadays. So I guess you all know this, but Kotlin was developed by JetBrains. It's open source. It has a lot of wonderful features. It's concise, safe, interoperable, tool-friendly. Are the same people that develop Android Studio. So we've got a win-win situation here. It's supported and used by Google for Android development. And this is the important point. It's more than just for Android, okay? You can also use it on server. You can use it on the web. You can use it natively. So you can almost use it on all platforms. To explain all the advantages of Kotlin, I will be speaking days and days in a row. So I decided to just pick the ones that I use daily, and I think they are the most important ones. No safety, no null, null pointer exceptions, default values, mutability, type inference, and a really important one, it's easy to learn. There is a really small learning curve involved when you want to learn Kotlin. And this curve is even smaller if you already know Swift and you want to go to Kotlin. The language are quite similar, and on this multi-platform approach, this makes total sense. So let's just see a small example. If you want to define a variable on Kotlin, you call it var. In Swift, it's the same. If you want to define a mutable field in case of Kotlin, you call it val. In case of Swift, it's let. So it's pretty similar. If you want to define a function, they are once again pretty similar. We have some difference here in string interpolation that we use the $sign on Kotlin and backslash and parentheses in Swift, and the way you return the type, it's also a big difference. To create an object, it's almost the same thing here. To access the variables, once again, it's the same syntax. But we're here to talk about Kotlin Multiplatform, and probably the first question that everyone asks is, what's Kotlin Multiplatform? Really simple answer. It's when you use Kotlin in projects that target more than one platform, right? Easy. So let's imagine this scenario. We want to develop an application both for Android, iOS, web, and desktop. So we typically will do the presentation layer, the model, the parser, the network, and then we're going to implement the view so the user can see the data and to interact with this view. And then we're going to do the exact same thing on all the other platforms. And although the views are are different because there is different ways to interact with this view. If you're using the mouse, if you're using a phone, the business logic will be quite similar because you're making a network request. The only thing that is going to change is the library or is the bit underneath layer that behaves differently depending on the platform. So what we want to really do here is to share this business logic, and instead of implementing it 4 times, we want to implement it only once and share it across all of these platforms. So this is the true goal of Kotlin. We want to share the application logic, and we don't want to share the application UI. Okay, and this is why it's different from the other cross-platform solutions. On Flutter, we want to share everything. Here, the goal is to share the application logic. The UI, you can leave it to native to be implemented as native as possible, as fast as possible. So, of course, we've got a lot of advantage here. So it's Kotlin first. It's Kotlin. So, yay. It's low risk because you can decide what you want to share. You don't need to share all your business logic. You can start small by sharing, let's say, the network model. If you're processing image, you can share the image processing model. If you can just share tests. I started by sharing tests, and I read that this is a common practice. It's interoperable, and it gives you consistency across platforms. For instance, if you've implemented the same thing the same way on all platforms, you don't risk having a bug in one and not in the other. Of course, if you have a bug, you'll also have the bug in all platforms. But let's see the cup as half full. If you fix a bug, you'll fix a bug on all the platforms. You also have a really good community support. I've seen this a lot of times. I've answered a lot of questions on Kotlin Lang Slack, and the people are amazing. You've got help from people from JetBrains, from the community. They all are easy to answer, and they all help you. So this is all your first reaction, right? Multi-platform. But let's talk a bit more about multi-platform. So how can we expect to communicate? Because I don't want to have on my code if Android do this, if iOS do something else. I want to have only Android code and only iOS code. So the way that JetBrains find that this would work best is to have the keyword expect when something is platform specific, and then I expect that someone will declare this, and actually on the other models, on the platform specific models, on Android, on iOS, someone will declare. Okay, these are the two keywords, expect and actual. But let's see an example. So let's imagine that I want to print a message that's going to display hello Android in Android and hello iOS on iOS. But this name is platform specific. So what you're going to do is to say that I expect that someone will define what name is. So I'm using the keyword expect. And if you see on the top right corner, I'm defining this on my common model. So it's on common main. And then I'm going to define what actually name means on Android and in iOS. So we switched from common main to Android main and iOS main to say that actually this means Android on Android and iOS on iOS. And the really cool thing here is that when you define the expect platform, the IDE will automatically say, well, you're targeting multi-platforms, you're targeting iOS and the GVM, you need to define what this is on those platforms, so you don't risk missing some definition. You can also just press Alt-Enter indeed to automatically create the classes. So basically, when you define the expect actual, in case the common model, you will later be importing it as a framework in case of iOS, and then as a Kotlin or JS on the other targets. There are some nuances when you want to start a Kotlin multi-platform. I've written a small blog post about this. You can find it on my Medium. There is a really good thing here because I've written one last year, and a full year has passed, and they've done a lot of amazing things, but there are still one or two places that you still need to do it. And I want you to just be able to create a project and start coding without multi-platform. So if you have any questions, go there and ask me any question that I'm willing to help you. It's also important to mention that TouchLab is a company that is really strong on Kotlin multi-platform, and there is a collection of code and tools that were designed by them and JetBrains to help you start with Kotlin multi-platform. It's called the Camp Kit, and it's an excellent starting point. Okay, on one of my last slides, I've got a set of useful links. This link is there, and I will share everything with you. So let's show the code. So when you want to do Kotlin multi-platform, you can use it IntelliJ for everything, or you can use IntelliJ and Android Studio. I typically only use IntelliJ. I do all my Android now on IntelliJ, and you also need to use Xcode or AppCode for the iOS part. I've already shown you a bit how the project is structured, but as you can see here, you've got your common main and common test for the models that are going to be shared. You're also going to have your Android main and Android test for the Android code, and then for iOS and GS, your iOS main and GS main for this platform-specific code. I've made a sample app to show this concept. It's a conference application. You can find it on my GitHub. And I'm just going to play here a video of everything working. So this is the project structure. As you can see here, it's the common main. I've defined layers to have all the information. The application will fetch the speakers list to the internet. We'll store it locally. Here we're saying that we're going to expect that someone will define the default dispatcher. Here we can see the implementation on the Android side. And now let's see the UI dispatcher in the iOS main. So if we scroll a bit, we'll see the implementation, the platform-specific implementation here on iOS. Here you can also see the database. In terms of database, I'm using SQLite. This library is amazing. It has a bit difference. You need to write the SQL instruction that's going to be compiled and generated into classes. Now you can see the Android code, and you can see that I'm coding Android normally. Defining here a recycler view, I'm opening the fragment, and I've got everything as I'm already used to. I'm still using the same libraries without any problem. We'll see this on further detail in a couple of slides. This is the application. I fetch this information from the internet. I'm navigating in the application. I make multiple requests. I'm going to like my own talk because I thought it was appropriate. And I'm just seeing the list of speakers, and then I'm showing the venue. So you're already familiar with the build folder. There is a bit difference here. Now we're going to have a bin and the iOS folder. This is where the compiled framework is, and this is where we're going to import it on Xcode. We've switched it to Xcode now, and you can see all the methods, all the functions that are defined on the framework and you can use. So now I'm opening the speakers view controller. I'm just opening the different classes. It's the same way as it was on Android. This is just Swift code calling code that is on the multi-platform side. Opening the app, you can see that it's the same behavior. It's important to mention that I'm no iOS developer, so it might not be the prettiest Swift code, so please bear with me. I'm also linking my own talk here again. And you can see that I only need to implement the UI because everything was already done, and I could easily share everything, all the logic with the application. So how is this project structured? There is a user interface. I use recycler view on Android, activities, fragments, and there is a UI table view controller and more on iOS. I make multiple network requests. I parse the objects. I store them on the local database. I have an offline mode, and then I notify the UI when there is new data available to be designed. Typically, and I know that this depends a bit on the developer, but typically these are the libraries that are used when you want to develop Android and iOS. So you're going to use Helm, Retrofit, JSON, you're going to do MVP or MVVM, you're going to use our Java, test, activity, and recycler view. And in iOS, you're going to use core data, Llama-Fire, JSON serialization, MVVM, RX Swift test, UI view controller, and UI table view. And the only part that it's really different, it's when you talk about UI. It's activity and recycler view and UI view control and UI table view. The other part are basically libraries that allow us to have less effort to get the data that we need, but it's unnecessarily duplicated. So what we're going to do with Kotlin Multiplatform is just merge everything and use these libraries that do the same thing and have different namings, or do almost the same thing but have different namings, to allow me to store the data on the database using SQLite, Tor for network access, serialization to parse the data. I'm going to do it on MVP, and I'm also going to use Kotlin Xcode routines and Kotlin tests for the tests part. So basically, if we have an high-level presentation of everything, would be similar to this. And the best thing here is that if you have iOS, it's the exact same thing. The only thing that changes is the bottom layer where we are going to have iOS components. You can see that we have 3 boxes, HTTP client, SQL driver, and dispatcher. These are going to be defined by the platform itself. This is why they are in the middle. And we'll see how can we do this on a few slides. So let's start. So we start by creating a Sessionize API class. Okay, I'm using Sessionize to get this data. And you can see that we receive an HTTP client engine. This HTTP client engine will be defined on the platform specific part. Okay, we'll see that on a few slides. So when you receive this engine, we're going to create a HTTP client, and you're just going to make a request to the Sessionize URL. I already know that I'm going to receive a JSON file, so I'm going to use Kotlin X serializer just to parse the entire data and give me a list, in this case, of all the speakers that are going to talk. This is really easy to do. This is the JSON response I received. So basically, I've got these attributes: ID, first name, last name, full name, bio, etc. I'm just going to create a speaker entity object that contains all of these fields as the name, and I'm going to use Kotlin X serialization by using the annotation at serializable, and then this data will all be parsed, and I will receive a list of all of these speakers. Pretty cool, right? As you've seen before, in order to have our database, this is the part that it's a bit different, because here we need to create the SQL instruction. So in this case, I'm just going to create a table, a speaker model table with an ID with a speaker. Here it's going to be a JSON string of the object, just a simple example. And then I'm just going to insert or replace speaker and get all speakers by calling select all. So basically what SQLite is going to do is to compile the SQLite code, and then it will output generated classes that I can later use without any problem. So here I've created a speaker DAO, data access object, just to allow me to easily add data and get data from the database. You can see here that I've changed the speaker entity to speaker just to have it a simpler object. It's really simple. It's still a speaker class, but with way less fields. And I've got here a method just to map a speaker entity to speaker, just it's easier to understand. Now let's go to the new main layer. So we want to get all the speakers, okay? So how does this work? So we receive as arguments the sessionize API and the speaker DAO, because you want to make the network request to sessionize, and you want to store the received information on the database. So what we're going to do is to call the fetch speakers. It was the first slide of code that we saw. And when this information is received, we're just going to map the speaker entity to speaker and then insert it on our database. If everything worked as expected, we're going to just call unsuccess. If for some reason it failed, we will call onFailure. So let's talk about a bit the presenter. So this presenter class, you can see that we have a method that it's not pretty common on the shared model, but you can give it another name, of course. It's called the attach view, and it receives an interface. So basically, this is the method that we're going to call on create or on view did load, for instance, and we're going to send an interface. Okay, this interface will later be called when the new data is available. So this iSpeaker data interface, it only has two methods defined: on speaker data fetched with a list of speakers, and on speakers data failed with the exception on why it failed. So once we've sent this interface, we're going to call these methods when we receive the on success that I've shown you before. So when we receive this data, we call on speakers data fetched. In case of failure, we're going to call on speakers data failed, and the UI will receive these callbacks with all the information that they need. Now, this is the trickiest part. I'm creating a service locator. What is this? Let's start by the last instruction. So there is a get speakers presenter. This get speakers presenter, it's going to be called by the UI. So it will be something like service locator dot get speakers presenter. And it's what's going to allow me to trigger later on that attach view that we saw before. As we can see, this get speaker, it will receive a sessionize API object and the speaker DAO that are initialized here. And we can see here that there is something quite different. I'm having a class named platform service location. And we typically use the prefix platform when there's something that is platform specific. In this case, it will be where we're going to define the HTTP client engine and the database engine. So you can expect, see the joke? You can expect that someone will define what this engine and database is going to be. Are you still with me? So checking the chat. Okay, nice. Nice. So here on our platform service locator, we expect to have an HTTP client and the database engine. So what we're going to do is we need to actually define them. So we've got this on our common main model, and on our Android main, we're going to use HTTP for this, and we're going to also use Android SQLite driver for this. That's given to us in SQLite. For iOS, we're going to use the same thing. In case of iOS, we're going to use iOS create, that is native, and we're also going to use native SQL driver that comes with SQLite. So basically, we expect this to be defined on our common main, and actually we define it on our Android main and iOS main. And this is how everything works. Now we are at our Android application. As I've mentioned, we've got our service locator.getSpeakersPresenter, and here we just call the attach view so the network request can be made. When this data is available, we call on speakers.fetched, and we just call the setup list so we can update our entire list. So this is an example of one bind view loader. So I'm using here Glide, so you can use all your libraries, the libraries that you're already familiar with it, without any problem. And I'm just setting the information to show on the recycler view. If we quick switch to the iOS, it's the exact same thing. I've got here the service locator. I'm going to call the get speakers presenter, attach view on speakers.fetch. I'm going to update everything. I'm going to do the exact same thing that I'm already used to. So there is always a big question here, how much sharing? So my direct answer is what makes sense for your app, okay? Once again, I'm a really good advocate at saying that start small and only increment as you're seeing the results, but it's up to you to decide what you want to share. Some conclusions. There is a new structure when you talk about Kotlin Multiplatform. Nowadays, you typically have an Android team and iOS team. Now, with Kotlin Multiplatform, you now have a mobile backend team. And if your application was using a C++ library, probably it already exists on your company or in your project. And the structure is quite similar. We have Android and iOS on top, and then you have the mobile backend that you use. It's really important here to have strong documentation, tests, and a clean API. Especially because of the framework that you see, all the framework code, it can become a bit difficult to, you can see the code, it might be a bit difficult to read. So it's really important to have the cleanest API possible and to have a lot of documentation explaining what each method is expected to do. It's also important to have tests because don't forget that if you have a share model, you're going to have the bugs duplicated on both platforms. So we don't want bugs. So let's try to create the most tests possible. I'm no iOS developer, so I've asked a friend if he could design one of the screens of the application that would interact with the common library with Kotlin Multiplatform, and this was his response. He answered, okay, I could just focus on doing what I know best, UI. I have no idea how things are being done in the backend, yet I know that when I ask for the data, I received it. So the feedback was pretty positive when I asked an iOS developer to develop using Kotlin Multiplatform. He could just focus in doing Swift code. It's important to mention, and as soon as you start working with multi-platform, you'll see this in a lot of places. It's still experimental, okay? It's not a final product, it's still experimental. Being said, there is also a couple of projects, or every time more projects that are being launched using Kotlin Multiplatform. During last Kotlin Conf, JetBrains announced Space, that is full Kotlin Multiplatform, and they showed a couple of examples. Some of those I've got here, that Cash App shares their business logic, Yandex Maps shares their business logic, wrappers for C++ libraries, Planboard shares the business logic, networking, offline caching layers. Okay, they decided to select what makes sense for them, and they started moving it to Kotlin Multiplatform and to share it across all their apps. So once again, it's important. It's still an experimental state. So this also means that sometimes you update a library and it can break your builds. Sometimes you update an Android library and a Kotlin Multiplatform Android library, and you've just broken something on the web. Okay, this is the most difficult part, but once again, you have a really strong community that helps you with everything that's going on. Start small. Don't try to reach 100% of shared logic. Perhaps start by writing common tests. I've done it when I switched from Java to Kotlin, and it was the same process that I've followed here. And start one model at a time. It's important to mention that this process of start writing tests, I've heard that it's usually the approach that most people follow because it's the one that has less risks. And take into account that you can spend some time resolving compilation issues, especially if you want to try to target all platforms. Being said, this is the sample that I have on my GitHub. It uses all the latest versions of the libraries, and I had a similar application made last year that I decided to update, and I probably spent like 3 hours, probably 4 hours updating everything. So it wasn't as difficult as it was a few years ago, but it took me a bit more than it usually takes when you're doing something on Android or on something on iOS. An important point is that so you're going to say to your iOS team, okay, you're doing amazing iOS code, but yeah, we want to do part of your code on Kotlin, so you need to convince them. I've read, I believe it was on TouchLab blog posts, that they say that there is a really good argument. It's to show them that there are things that are really painful on iOS and are far more complex there, that you can convince them to switch to Android. To switch to Kotlin Multiplatform. And if you want, of course, also convince them to go to the light side and go to the Android. One of these examples is core data. It's really tricky to work with core data, and if you have a shared model, you can easily do this. Once again, it's important to mention that Kotlin Multiplatform is not intended to share the UI. So iOS developers can still do their UI in Swift, or if they want, they can even have Kotlin Multiplatform with the UI made on Flutter. There is no problem here. One of the arguments that people mentioned last year, there was no direct way to debug Kotlin Multiplatform or the multiplatform model from Xcode. This is not entirely right because TouchLab launched a plugin that allows this, and the full support has been mentioned by the JetBrains during the last Kotlin Conf. So some more final conclusions. It's a really strong community, okay? If you're not on the Kotlin land slang, go there. It's really, really amazing Slack. A lot of people are already using Kotlin nowadays, so the switch to Kotlin Multiplatform, it's not that hard. It allows 2 times faster to develop your feature business logic, 2 times faster to write unit tests, and one of the most important points, it's one tech stack. You've got consistent across all platforms, okay? I've got some links here that you can then access. It's just some libraries that I'm currently using on different side projects using Kotlin Multiplatform. These libraries are really, really good. Some are from JetBrains, others are from the community, and there are really cool projects to follow. There is the Kotlin Conf app, the Droid Kotlin by TouchLab, the Camp Kit by them, the Sudoku Playground by Yosek, there is People in Space by John O'Reilly, there is the Kotlin Game of Life by some folks at JetBrains, and these workout MPP. Some final remarks. I noticed that tomorrow is going to be another talk about Kotlin Native. I believe this talk is going to be on French, but it's about Kotlin Native, so it's also a good way to learn. So that's it. Let me open the questions. So everyone is still alive. Okay, so I believe you are seeing my screen. Okay, right. So let's start by the first one, how it could be different than third-party tools like Ionic, Xamarin, etc. Will there be a limitation to have native UI parts? Okay, there is no limitation here because you're going to do everything native, okay? So since you're only going to do the common model on Kotlin, there is no limitation here. You're still going to do everything that is native. How big a compilation overhead, for example, if I take to spread, oops. How big, whoa. For example, if I take my 2 separate app and put them in multiplatform without sharing code, should I expect any overhead? Without sharing any code? Well, on multi-platform, we will need to share the code. Talking about compilation overhead, of course, that since you have a new model that needs to be generated, for instance, you will need to generate a framework. So it will take you a bit more time, but it's not something that is drastic. You don't increase your build times by 10 minutes, for instance, although it depends a bit on the project and you'll see a bigger compilation time. But it's not something that will create a big overhead. Also, it's important to mention that, for instance, if you're using a C++ library, the time that it takes to compile a C++ library and the time that it takes to compile this model, it will be lower. The questions are moving aside. Not able to impact app performance and app size. Well, this is the trick. This is a tricky one because it depends a bit. The app size, I would say that it will be probably a bit higher, but it's not so much higher than that will affect it. So I've made a test on application that had 5 screens and it increased 1.5 megabytes of size. About the performance, once again, it depends. If you're using a C++ library, this will be faster because you don't have the GNA bindings to work with. So it will be an improve there. If we're talking about only F code done on Swift, okay, we'll have a small overhead, but it's really low. How the new iOS version compatibility will be managed. So this will still be done on the iOS side. So I believe there will be no problem here because you will still have your UI done on iOS. So only the shared code will be done, will be shared. So it will not impact the common model. Yeah, there is limitations in terms of debugging, especially on the iOS, because you cannot debug on Xcode, but the people from JetBrains are already solving it, and TouchLab already launched a plugin that that fixes this, and it allows you to debug. Yes, you can use IntelliJ Community Edition. I need to look at the codes, but I believe in case of iOS, I was doing the dispatch after. Have you considered putting a presenter in the shared code? Yeah, this is a really good question. I've seen it a couple of times. I've seen it in a couple of times. I think you don't have any direct gain of doing everything on the shared model because I want to freely do my Android code and test Android libraries without any problem. I've also seen some projects, for instance, that did the entire UI on Flutter and everything worked as expected. So this is honestly, it's up to you as you prefer to do everything. So I think we're a bit out of time, but I will try to answer one more question. So yeah, well, it was different, let's say. I was already pretty familiar with retrofit, so doing things with Qatar were a bit different, especially because I believe they updated the library somewhere in January, and I had to change a few things, and I wasn't already used to. So I don't know if I can still answer to some more questions. Let me just grab another one. What is the dependency injection library used inside the command line or platform related? Well, once again, this depends on your feature. You can do it on both sides. Honestly, probably as a first, I would start doing it and wait. I would probably do it on the platform first. So last question, I would say is up. Okay, is Apple really okay with Kotlin Multiplatform? Our app got kicked for the store because of it 2 years ago because it was using reflection. Well, I've got an application on the App Store without any problem. The only thing that they don't like is having an application called Android. Not sure why, but if you call it Robot, it will pass. I didn't find any problem with it, to be honest. I know that we have a few more questions here. There is a Slack channel that was created for this. I will try to answer all of these questions remaining there. If you have more questions, please be free to ask them here or to ask them directly on Slack or ask me directly without any problem. I hope you've all enjoyed, and once again, thank you so much.